Well, in, in this second presentation, we will look into the circuitry comprised in the basic boundary scan cells. So after watching this presentation, you should be able to explain how the circuitry inside its basic boundary scan cell is able to control and observe any functional pin. And you should also be able to explain why these boundary scan cells have little or no importance during the normal circuit operation. So in this slide, what you see is a representation of the basic circuitry that is located inside each of these cells. And you can see here that the basic circuitry comprises nothing more than two small multiplexers and two small memory elements, flip-flops or latches. Actually, we have two stages, what we might call the input stage or capture shift stage. You will see in a moment why it is called capture shift. And also the output stage, or the so-called latch stage. And when we power up the circuit, this is how the output multiplexer operates. So in this case, the parallel input of the cell is directly connected to the parallel output. That is to say, the cells are operating in transparent mode. All the pins are connected to the core circuitry because the output multiplexer establishes this direct connection between the pins and the core circuitry. We can, however, use the input multiplexer to alternate between the so-called capture mode, whereby at the rising edge of the test clock, this flip-flop will capture what comes from the input of the cells. So in this case, all the cells would capture the logic values that were present at their inputs. All the cells operate at the same, in the same mode, and they receive the same test clock. So when you drive a rising edge at the test clock input and the input multiplexer is in this mode, then all the cells will capture the logic values that are present at their parallel inputs. And then by switching the input multiplexer to the so-called shift mode, you will have established a serial path that goes through the entire printed circuit board. So you can actually shift out the values that were captured at the input of each cell. And this means that you can indeed alternate between capturing the values at the input pins and shifting them out for observation. And by capturing the value of at every input pin, or even output pins as well, what you are doing is taking a photograph of the circuit condition at that moment. And then you shift it out, and you take another photograph, and then you shift it out, and by repeating this operation, you can actually build a movie that describes the operation of the circuit. And this can take place while the circuit is operating normally, because the boundary scan cells are in observability mode, or transparent mode, as it is called as well. Actually, some logic analyzers use the boundary scan infrastructure to capture and display the logic values during circuit operation. Now, the other operating mode is the so-called controllability mode. And in this mode, the output multiplexer isolates the core circuitry from the pins. As you can see here, the output of the cell no longer comes from its parallel input. So this connection from the pin to the core circuitry has been broken in the case of the controllability operating mode. Well, in this case, you can still alternate between capturing and shifting modes. So you should be able to figure out that testing a board basically consists of, well, we start with the circuits in transparent mode, Then we can set the input stage such that we can shift in the first test vector, and the circuit might still be operating normally. And by setting up this scan path, we can send in this 1 and this 0, for example, for detecting this short circuit. Then we set the cells to controllability mode, and when we do so, the outputs no longer come from the core logic, they will rather come from the latch stage. So in this case, what will happen is that the output pin at this point will receive a 1, which was the value that has been loaded into the latch stage. And this output pin will get a 0, and this is independent of the logic values that might come from the core circuitry. And then we can capture the test responses, that is to say, by setting up the input multiplexer in this mode, the cells located at the other end of these interconnects will capture the 1 and the 0. And then by again setting the shift mode, we can shift the test responses out to be observed. And then we just have to repeat this process of shifting in a test vector, driving it to the outputs of the cells, and then capturing the test responses, and again shifting a new test vector. You should notice also that while you are shifting out the test responses, you will also be shifting in a new test vector. And this is how the boundary scan test technology operates. You simply alternate between shifting, driving, capturing, shifting, driving, capturing, and you can find out any structural fault in the printed circuit board. Thanks for your attention.